Nice, isn't it? Hello there, IPC students. Welcome to week 5, lessons 9 and 10. Little quick overview. You caught me there just enjoying the day turn into night. It's one of my favorite things to do. One more time, let's watch it. Nice, huh? Put that in there as a joke because I know it shows up later. But I actually do, that is one of my favorite times of the day. The daytime's turning into night. Pretty cool background picture there. Am I right? Quick little aside here. Let's see here. Can you see that picture there? It's not showing up too well in my picture. Right down in there. See the blue, so there's a little bit of pink there above the sky. This is a picture I took at the beach. And then right down there's a little bit of blueness. Do you know what that is? The shadow of the Earth. So in this picture here, the sun is setting on the other side, right, like behind me. And so that means the Earth was casting a shadow onto its own atmosphere, right, because the sun's over there. I also love to try to find the International Space Station, by the way. Man, that's a good time. Anyway, that's pretty cool. So here's where we are. Week 5, lesson 9, so make sure you're there. It's 27 to 30 in your quarter 4 packet, so you got a little question there to talk about. Some of this we've actually talked about previously. This has come up before. What do you know about the Northern Lights? What do you think causes the Northern Lights? Go ahead, think about that for a second. There's a video for you to watch, but if you remember back to what we had talked about, a good example was the fluorescent light bulbs. Remember, we touched them, the ball, and it lit up, and we were just exciting the electrons in there and jumping to higher energy levels and then jumping back down and releasing the light. So the same thing that's happening in the fluorescent bulb as we send electricity through there, exciting those the electrons. Essentially the same thing happening with the Northern Lights, and they'll be talking about that in the video. So it's particular elements that we're talking about. So, and you're going to read about this also. An important thing to make sure you get out of this is that every single element, remember when we talked about elements, and we probably said this before too, I'm sure I said this, every single element has its own fingerprint. Just like every person has a distinguishable different fingerprint than everybody else, every element has its own spectral fingerprint. And so these lines here, it says when an element is burned or supplied with energy, the pattern of light emitted from it is called an emission spectrum. So it will emit energy in the form of light at very specific parts of the visible spectrum. And you can see right there, there's 400 nanometers, 700 nanometers. So this is the visible part of the spectrum, like we just learned about. And so if it's hydrogen, it'll have those lines in those exact places. If it's mercury, it'll look exactly like that. And then if we see another one, it has these lines and these exact places and this pattern, and we'll know that it's neon. So that's pretty cool that every element shows off a particular spectrum. And we can look through an instrument called a spectroscope, and we can actually identify an element in a variety of situations by these spectral lines. And then there's absorption spectrums and stuff too, but this is just the emission spectrum. And essentially then it works like this, kind of going back and forth there, back to the like how the Northern Lights work. There's an animation here, so this should definitely work for you, and it's pretty cool. You get to click on things and jump the electrons back and forth. And so essentially what happens is energy comes into the atom. It's this electron way down at this energy shell. Remember way back we talked about the electron levels. And then so when some energy enters that electron, it has to jump up. In this case, in this picture, several energy levels because it jumps up to a higher energy state. So it's up here, all excited with more energy now. And then when it releases that energy, it jumps back down to a lower state. But we know energy can't be created or destroyed. So it came in from somewhere, and then when it left in the form of light, a specific color of light. And so then we see the fluorescent lights, or the aurora borealis, or northern lights. Okay, and there's a video there. This is the same thing. This will make more sense. So watch that video about the flame test. There's some note pages to fill in. Then there's one of these PhET simulations. I know they haven't been working. Maybe this one will work. This is one of the problems right here. It won't work on a device without Flash Player, which I think they're phasing Flash Player out, so I'll have to update these or something. Try to get it to work. You know, if it doesn't work, find a way around it. When you look at the slideshow, there's a couple of other things. They give you some of these pictures in there, so you can just use those and try to answer the questions with those. Okay, and then you're on to lesson 10. So pages 30 through 32 in your packet. How does the electromagnetic spectrum relate to stars? Remember back on this, at one point you were supposed to have filled this in on an older thing. So this is the whole spectrum, right? There's the visible part of the spectrum that we were just talking about, right? Red, orange, yellow, green, blue, violet. There's everything. What you're going to be doing then is going to explorelearning.com and using the Gizmo star spectra. So in the packet and on here, it tells you to use this username and this password, and that's fine. That should work. Remember, you've already made a explorelearning.com account. We've done gizmos before, so if you want to use your own, I put the star spectra in each class, so you can just, it should be right at the top of the list. So it's up to you. If this doesn't work, log into your own. Okay, so we got a little chart here, real quick, about stars. So cool thing, when you're outside at night after the sun goes down, you've watched it, the shadow and everything, and then there's the stars in the sky. So just by looking at their colors, we can tell a lot about the stars. One, their temperatures, right? We know that a yellow star is going to be hotter than a red star, but a blue star is going to be hotter than a yellow star, okay? Red, orange, yellow, green, blue, violet, right? Just from that. And really, in the case of stars, now we know their approximate temperatures, their surface temperatures. And now, talking about the spectral emission lines, we can also know what elements are there, right? So that spectroscope, we can look at stars, we can look at the sun, we can look at nebula gas clouds, we can look at other galaxies, sort of. Eventually the technology will be available. We'll be able to use a spectroscope probably and look at planets going around other stars and identify the gases that are in the atmosphere based on the spectral analysis of them. So that's pretty cool stuff. So that's kind of what you're doing in this this gizmo here, identifying some things there. Check your answers. And then towards the end, this will maybe be the hard part too. These are all the known elements, right? This is what calcium looks like. That's what helium looks like, hydrogen, lithium, sodium, and so on. And then here's a little scale of nanometers, right? So you can tell exactly where the lines are. And then they give you 3 samples, right? So based on these lines, so you're looking, oh, there's one thick line there. And I think on your page, they'll all be lined up straight, so you could look for them and be like, aha, it's probably that one. So there might be several in there. So you're trying to identify what elements are in there based on the known elements. All right, not real long. Again, submit everything, and it's learning. It's good to see so many people doing so many assignments. I really appreciate that. Everybody's sticking with it. So I know it's an odd situation being at home and working on this on your own, but everybody's doing a good job. So at this point, we know not getting back together. So this is how the year is going to end, this way online. So there'll be a few more of these, and then we'll be wrapped up for the year. Okay, talk to you soon.